Hey guys, welcome back to Algebra 2 lessons with Miss B. We are doing lesson 15.1, Logarithmic Functions Part 2. In the last video, you learned how to write exponential functions as logarithmic functions and logarithmic functions as exponential functions. In this video, we're going to talk about how you can evaluate logarithmic functions. Okay, so here we have our two formulas. We have our exponential, okay, and we have our logarithmic. Now, when you're evaluating these logarithmic functions, the first thing you need to do is convert this to convert to exponential form. Okay? So I'm going to identify my parts of this. So I've got B, X, and A. Okay, so my A is 1,000, my B is 10, and my X is X. Okay, so I'm going to do 10X equals 1,000. Now, in order to do this, you need to convert your value over here to an exponent, okay? What I mean by that is this is your base 10 here. You can see that 1,000, so you can get 10x equals 10 to the power of something. Okay, so 1,000 is 10 to the power of something. And now we know that 10 squared is 100. So 10 cubed would give us 1,000. So then you just use the rule that when you have these, the common base, you could just cancel them out. And you get x equals 3. Okay, and that is how you solve for this particular function. So we're going to do another one. Okay, we're going to get the log of 10 times 0.01. Okay, so I'm going to start by setting it equal to x. Okay, I need to convert, so I have b, x, and a. So x is x, b is 10, and a is 0.01. So I do 10 to the power of x equals 0.01. Now, I need to convert this into a value of 10. So I get 10x equals 10. Now, I need to find what 0.01 is 10 to the power of, okay? When you see a decimal place like this, you're going to say that your exponent is going to be negative, okay? So my exponent has to be negative. So 10 times negative 10 times negative 1 gives me 0.1. 10 times negative 2 gives me 0.01. 10 times negative 3 gives me 0.001. Okay, so I'm going to pick this, and I'm going to do 10 to the negative 2. I know that my common bases can cancel, and I get x equals negative 2. Okay, now those are some pretty simple examples, so we're going to get into some harder ones coming up. So here we have log 8 to the power of 2. I'm going to set it equal to x. I'm going to convert. B is 8, x is x, and a is 2. Okay, so I get 8x equals 2. Now you might be thinking, Miss B, there is no way that I can make 8 equal 2. And you're right, 8 does not equal 2. But there is a common denominator between 8 and 2, and that's 2. So I can say that 2 to the power of something gives me 8. Okay, 2 times 2 equals 4. 2 times 2 times 2 equals 8. 2 times 2 times 2 times 2 gives me 16, and so on. Okay, so I'm going to say that 2 to the power of 3 times x equals 2. Okay. And this is just 2 to the power of 1. Okay? So what you would do is you would just do, okay? So now when you have an exponent outside the parentheses, you would say that these are going to multiply. Okay? So I get 2 to the 3x equals 2 to the power of 1. These are going to cancel, and we get 3x equals 1. And I divide by 3. By 3, so my x equals 1/3. Okay, So here we have log 8 to the 1 over 32. Okay, so I'm going to convert this to I'm going to set equal to x and convert to my exponential form. I get b equals 8, x equals x, and a equals 1 over 32. So that gives me 8x equals 1 over 32. Okay, now this is something new again. We have a fraction and we can't get 8 to go into 32. Okay, 8 to the exponential power of something does not equal 32. Okay, 8 squared is 64. But again, there is a common denominator, and that's 2. So I can say 2 to the power of 3, as I just did in the last problem, times x equals 1 over 2 to the power of something. Okay? So I need to know what 2 to the power of something equals 32. All right, so I know that 2 squared equals 4, 2 cubed equals 8, 2 to the 4th equals 16, and 2 to the 5th is 32. Okay, now if you don't know that off the top of your head like me, who's been doing these problems enough that I can recognize this pattern, is you can just plug it into your calculator. Okay, you do 2 times 2 times 2 times 2 until you figure it out. All right, so this is 2 to the 5th. Now, when you see something that has a fraction, another way of writing 1 over 2 to the 5th is 2 to the negative 5. Okay, that's how you would do that. So I'm going to say 2 to the power of 3x equals 2 to the negative 5. I cancel these out, get 3x equals negative 5. Okay, and I'm going to move over to here since I don't have enough room. I do 3x equals negative 5. Divide by 3 on both sides. And my answer is x equals negative 5 thirds. Okay? My next one, the log of 16 and 4. Okay, so I'm going to just I'm going to set equal to x, and then I'm going to convert to exponential form. b equals 16, x equals x, a equals 4. Okay, so I get 16x equals 4. Now again, 16 to the power of 1 is 16. 16 to the power of 2 is 32. Or not 32, sorry. 6 is a larger number than that. I don't know that off the top of my head, but it's bigger than 4. All right? So what I need to do is I need to find a common denominator between 16 and 4. Now, I know that 4 goes into 16, so I'm going to do 4 to the power of something, x equals 4. Okay? Now, 4 to the power of 16, that's just, or 4 times something equals 16. So that's 4 to the power of 2, okay, equals 4. So this is 4 to the power of 1. Any regular number is 4 to the power, or is to the power of 1. So 3 is to the power of 1, 2 is to the power of 1, 5 is to the power of 1. Okay, so I go 4, 2x equals 4 to the 1. I cancel these out. I get 2x equals 1. Divide by 2, and I get x equals 1/2. Okay? Here's another example. And here I'm going to set equal to x, and I'm going to convert to exponential form. My b is 9, my x is x, my a is 3. So I do 9x equals 3. Now I need to find a common denominator. Okay, so I know that 3 goes into 9, so I'm going to say 3 to the power of something, x equals 3 to the power of 1. Now, thankfully, this is a really simple one. I know that 3 squared is 9, so it's 3 to the power of 2. Okay, so I get 2x equals 3 to the power of 1. These cancel out, and I get 2x equals 1. Divide by 2, and x equals 1/2. Okay? So, here we have this equation. Okay, and they want us to solve. So we're going to set equal to x, get b equals 3, x equals x, and a equals 1 over 27. Okay, So I get 3x equals 1 over 27. Now, I have 3x here, but I need to make 27 to something that I can have a common denominator with. Okay, so I'm going to say 3x equals 1 over 3 to the power of something. I know 3 to the power of 1 equals 3. 3 squared equals 9. 3 cubed, that's 27. Okay, so I'm going to say 3 cubed is 27. So I write 27 as 3 cubed. Now, 1 over 27 can also be written, or 1 over 3 cubed can be written as 3x equals 3 to the negative third, or to 3 to the negative 3. So I get x equals negative 3. Okay? So I have this equation that I need to solve for. I'm going to set equal to x for this example. Draw a line there. So b equals 2, x equals x, a equals 1 over 64. And I plug it into my equation. I get 2x equals 1 over 64. Okay, now I need to find a common denominator between 2 and 64. So I know that I can say that this 2x equals 1 over 2 to the power of something. Okay, now I need to find that out. So I know 2 squared equals 4, 2 cubed equals 8, 2 to the 4th equals 16, 2 to the 5th equals 32, 2 to the 6th. That seems like my lucky number. That gives me 64. Okay, so I'm going to put 2 to the 6th. Now, 1 over 2 to the 6th can also be written as 2 to the negative 6th. So I'm going to rewrite this as 2x equals, I'm going to move this really quick. Move this over here. Okay, 2x equals, actually move this so that I have more room. So I'm going to get 2x equals 2 to the negative 6. Okay, this cancels out and it's just x equals negative 6. And that's my answer. For our final example, okay, they give us this equation. I'm going to set it equal to x. I get b equals 81, x equals x as always, and a equals 3. Okay, so I go 81x equals 3. And you might be thinking, oh no, I don't know 81 and 3. What's a common denominator? Well, 3 has to be our common denominator, right? So if you plug it into your calculator, you see that 3 does go into 81. Okay, so you can do 3 to the power of something, x equals 3 to the power of 1. All right, so you will find that, so 3 squared is 9, 3 cubed is 27, and 3 to the 4th is our lucky number, 81. Okay, so I put 3 to the 4th. Then I rewrite that as 3 to the 4x equals 3 to the power of 1. These cancel out, and I get 4x equals 1, divide by 4, and I get x equals 1/4. Now, I know that I just did a lot of examples, but if you still have questions, that's okay. I'm going to be posting a lot of worksheets and a lot of problems, so please email me, message me on the Remind app, or text me if you have any questions.